So this session in particular is titled Using Query Store to Fix Plans and Pains in Your Queries. I'm Pablo Lozano Fernandez, a SQL Server DBA with almost 10 years of experience. For the last year and a half, I've been using Query Store very extensively, and this session is trying to help you get introduced to Query Store, since I feel this is a feature that is rarely used. Most places it's not being used at all, and from which I think that all us DBAs could get much more information, get much more improvements than we currently do. So what's Query Store and why should I care about that at all? So think of this tool or feature as a combination of a SQL trace on extended events, with which captures information about query executions, but instead of the individual ones, it aggregates the data. For individual ones, you already have the profiler, extended events, you can have all the details, but a Query Store aims to just get you some aggregated results. So this captured information includes the execution times of all your queries, the result consumption of your queries. This might be logical I/O reads or logical I/O writes, 10 DB usage, memory, CPU. It also includes, starting in, I think it was 2017, it also includes the wait time, so you can tell what resources were your queries waiting for. And all this information is being stored within the database you activate it on. So it will survive server crashes and database migrations. There are some traces you can set to make sure that it will also survive this without any issue, that will flush the data into this before shutting down the servers, and it will work pretty much every time. But just don't rename the databases, because that will mess the execution plans it stores. So how can Query Store achieve all this? Store all the information, do the aggregations. We're going to take a brief look at how it achieves that on a very high level. First, we have to identify the query. So the SQL query reaches the SQL instance, and at this point, the SQL engine tries to identify it and figure out if it has been executed in the past. There might have been records of previous executions, so the SQL Server already has an idea of what to do based on those previous executions. Or this might be a brand new query, which has to be compiled. And then Query Store gets a plan for the query. So it looks for the available plans. So for new queries, that will be just the new one that's just been compiled. So this step is pretty straightforward. If there is a forced plan, I will explain more on that concept later. That will be the one that will be used by the SQL engine, provided there are no breaking changes like dropping indexes or changes that have such an impact on the SQL Server that the SQL engine decides that that plan is no worth it anymore, and it should be using a different one. Otherwise, if there is no forced plan, it will try to figure out which one of the existing plans it has archived could be used for this query. Or maybe if none of them matches the query, or it considers that a new one could be produced, it will create a new one. And this plan is labeled as SQL Server as good enough, which was very funny when I found it. I found it very, very funny, because it was not a production issue, so that's why I had the time to find it funny. SQL Server just keeps up when it considers has analyzed enough plans and has found some that are good enough to be executed. So that will not be trying to generate thousands of different plans and taking more time just generating a plan than actually running the query with the plan. So now it's when the SQL Server does its magic. It executes the query, whatever it is. So it may include some reports to the user, or just from some process we know output to the user. And it logs the details of that information, of the operation. How long to complete, what resource we had to wait for, whether that would be CPU, I/O, network, whatever process had to wait for, and it stores that all that information temporarily in memory. But we don't want all this raw information for the serial execution. For that, we already have profiler and extended events. we need some aggregation, some statistics obtained from that information. Also, all this information, as I mentioned before, is being stored in memory, which is great for performance, just to do the calculation and to store it on the fly when the queries are going, but it's not so great when the server crashes. We want to know what might have gone wrong before a crash, so query store may be helpful to investigate that. So now we have the execution plans of every single execution details, or every single execution plan used for our queries. Then they are aggregated to calculate the different measures: maximum duration, average CPU, minimum memory consumption per execution plan on a given interval. And the duration of that interval can be adjusted later, so we can decide whether the data will be aggregated per 15 minutes, an hour, a day. And then when we have all this data aggregated, it's flushed to disk, where it's pretty much safe. So the data is somewhere, but the data is useless if we can't access it. So we are going to be using SQL Server Management Studio for that. Since every one of us has different needs for the reports, there are some predefined reports that are meant to cover all of our needs. This might include regress queries, those whose behavior has deteriorated lately. Let's say that they are taking more time now than they took last week, or they're consuming more memory, or the I/O has increased. Those are the ones that will pop up in the regress queries report. The overall resource consumption, which is a quick view of each resource consumption of the database, so we can see how much CPU the activities on the database are taking, how much I/O are consuming, how much 10dB. And we have also queries with force plans, which I will explain later, queries with high variation from their mean metrics, and the query weight statistics. And for specific queries, once we have identified one particular query we're interested on, and let's say we want to monitor that today, tomorrow, and next week, we can have information from each specific query. So Query Store has some reports for that. You have multiple metrics you can build your report from. That be duration, CPU, I/O rates, 10dB usage, memory, even the log space usage. You have all these metrics to select from, and for each of those metrics you can use different statistics. So, for example, maybe you're interested in the maximum duration, since that means that your application is connecting to database, and if the duration is too high, it might cause some timeouts. Or your concern is the total I/O your queries are consuming, to try and identify those whose performance might get an improvement, boost by migrating to another storage, or compressing your data. So the SSMS provides a UI to access that information with some graphical representations, very useful to show some specific pain points to know where to start working on. We're going to see some of them here on this demo. Okay. Let me load some scripts to prepare some data. So first of all, I'm gonna just clean the query store cache that I have on this database where I've been doing some demos before. It's just a copy of AdventureWorks, so there's nothing weird on that. So what I'm going to do right now is I'm gonna run some queries, so the information will be loaded into Query Store. Wait for a minute and then run the same step procedure with different parameters. I made some tests on this, and depending on the parameters, there is more or less data being loaded. So that will let me see what kind of information I can get from the reports, and might find some graphics to represent that. Yeah, there is a lot of results, blank results here that show no information at all. These are the ones that I will be using as a baseline, and then I will be comparing them to the same reports, but with information. So I'll just have to wait for a few minutes I have some other things I wanted to share. Okay. Since I knew that will take some time, I prepare also some reports here. So this is another database. Let's say the default, it will always default to the same kind of report. There is no way to hard code it, unfortunately. It will just go to the top 25 queries in terms of total duration. So I have somewhere, let me see, I have the query run over here. Just going to identify the query so I can show you one with some specific metrics or something to look at while we're waiting for the other data to be loaded. So this kind of query, this is what I jokingly started calling the rainbow queries because they generate multiple plans. And the rainbow queries, obviously, because of the amount of plans here that paint an interesting graph here. Okay, so this query is almost there. So the reason for these different plans is just I force that. It's not something that you should be seeing normally. So what I did was just start creating and dropping an index, the same index every single time with a different name. So the SQL Server will have to create a new execution plan. And that's why there are so many execution plans. But if you take a look here on the bottom, you will see that all of them are very simple queries, very simple index, very simple execution plans, and the only change is the name on the index. It's almost there, just a minute or so. Well, we can see some of the reports here too. So we have the top resource, the duration, the CPU duration, sorry, the total duration in milliseconds. We have a bunch of them. As I mentioned before, there are a lot of metrics you can select from. The execution count, the duration of the query, the CPU that the query has consumed, the logical reads and writes of the query in kilobytes, the physical reads, the serial times, the degree of parallelism, memory consumption, row counts, log memory, 10 dB, and wait time. And for the statistics, we have the usual average, max, minimum, standard deviation, and the total. I think this is already done. Yes, the query is done. Oh, not this one. So this was the AdventureWorks 2017. I'm just opening here query store. And let's see the request queries. The default values are not the best ones. It always defaults to looking for request queries that have a performance worse in the last hour than they had last week. But I couldn't wait just to have a 1 week worth of data here. So I'm gonna customize the values. I have here in the results the times that each of the steps started. So one started at 7:40 UTC. Okay, what is it? Yeah. It's 27th. So the recent will be 43 to 45. And the historical data that will compare the results from will be 1940 to 1943. Let's see if we can get something here. Yes, we can see there is only one stop procedure here because I've been only using 2 of them. And as you can see here, Well, you can read that the total duration recent is 36 milliseconds, but the history, which was just 1 minute ago, but with a different parameter, was under 10 milliseconds. So we have the metric here about the additional duration. This is the total, but we can see the average duration, which is the measure is in percentage. So it was a 288% of increase, and here we can see there is not much data here. There's not many intervals here to look into, but you can see that here in the first interval between 1940 and 1941, the average duration was under 1 millisecond. But then between 1943 and 1944, the average duration raised to 3.7 milliseconds. So that's an increase, and that's what the query store will consider as a regress query. I will highlight it to you. There are some other reports, as I mentioned before. The overall resource consumption is not much here to see. Okay, in the last hour. So you can see some peaks when it's been running. So if you have a database with a lot of activity, you might see here what would be the peaks of activity on that particular database, not only on the server. So that might be useful for you to find some peaks of activity on one particular database, not just on the server level, in case you have too many databases to choose from. Some other reports we have. The top resource consuming queries. So if you're having some issue, if you want to start just with the top query, and then go down one step at a time, one query at a time, until all your queries have a low duration or low CPU, you can just select this kind of report. And if you don't like these graphs too much, or if you want to get information from each query quickly rather than just hovering on the query, you can just change the views, and you'll see more information here, even the object name, which can be very useful to identify exactly the ones you're interested for if you're just looking for a particular store procedure. So back to the slides. You have the request queries. You have the overall resource consumption. You have the top resource consuming queries, which can be useful if you want to get rid of the top ones and then go lowering each of them. And the queries with for plans. Queries with for plans. I show you what will happen when you have multiple plans. So we are going to see what happens when you try to force a plan and what happens when you can't do that. Okay, so first of all, I'm just going to clear the query caches again on the same database. I'm going to run this query that will use the primary key, since there is no index that includes both the state province ID and the city. Okay, now we need to identify the query ID and plan ID so we can force it. We can do that using the interface or using T-SQL. So I'm gonna see how we are going to first identify the query using the interface. You can see there are not many queries here, just the one actually. The second is one internal query. And the one we have here is the one I'm interested on, is this query ID. We have the query ID is number 1. And then we have the plan ID, which is also number 1 because it was the first query executed after the cache was claimed. So we know query ID 1, plan ID 1. We can execute this command to force the plan, or we can just click here and force the plan. Forcing the plan will tell the SQL Server that whenever possible, unless there is some catastrophic error or something that prevents it from using the plan, it will always try to use that particular plan for the query. So now I'm going to create the index just in these particular 2 columns, which will be the one that ideally we will be using. I'm going to try again running the same query. Okay, since I have the query selected already, I can just click it here and just go to the track queries here. So you don't have to copy and paste the ID of the query. Again, zoom in for the last minutes. Okay, so I executed 10 times each query. We have the 10 executions here, and then a minute or so later, we have the same thing, the same query executed 10 times. But as you can see, there is only one plan, and that plan does a seek and then a key lookup. But it is not using the query I created. Yeah, this is because, as I mentioned to the SQL Server, as I told the SQL Server, it should be using the old plan and ignore any other plan that comes across. So I'm gonna try again. I'm gonna try to force the plan for the new query. First, I'm just gonna remove the force plan. So they will tell the SQL Server that it's okay to try and find a new good enough plan that is better than the current one. So I'm going to run the query again, and let's see if the new plan is identified and generated. So we're gonna refresh that, and here we can see this plan number 8, and here is using the plan IX forcing demo. So I'm gonna force that plan just to ensure that the SQL Server will, whenever possible, use that particular plan for this specific query. Okay. So I'm just running the same query 10 times again to confirm that it's using the force plan. Yeah, and we can see this is the first time I executed the query without forcing the plan. And this is after forcing the plan that it didn't try to generate a new plan, or didn't revert to the previous plan either. So now we know that SQL Server is acknowledging my recommendation and is using the plan I'm trying to force. But what happened when I drop that index? I just dropped the new index, and I will see what happens to the SQL Server. Yeah, there is no error, so the SQL Server has found another plan. Okay. Come on, you should be using the previous one. Yeah, it's gone. There it is. So it's back to using the plan number 1. So just notice that I didn't drop the plan. So I didn't remove the plan anyway. I didn't unforce the plan. And the SQL Server didn't crash. So it didn't recognize that the plan was no longer valid, and it didn't just crash. This is a difference with query hints. When you try to force using a particular index, if you make a change to the index, you might have a lot of errors. You might be unable to run that query anymore unless you change the whole code. So this is a nice improvement, because you can somehow try to force the SQL Server to use the plan, but it's not so strict as a query hint. And sometimes we get some information about what happened to the plan. Let's see if it happened this time. No, it didn't happen. Yeah, this particular view, turning recommendations, it will usually, not always, I don't know exactly what triggers that. When the SQL Server detects that a plan is no longer valid, or there is a better plan than the one that you're using or that they're forcing, it will log some recommendation here. They might log the recommendation to, okay, I found this particular plan that I think it's better than the one that you were using. Or it will log in the same row the information about, okay, I'm no longer using that plan because I found out that this other plan I got here, either a previous one or a new one, it's better than the one or I have been using so far. So I think it will be better for you to get this one. Okay, so this is how forcing plans and unforcing plan works, and how it will not mess up with your queries if you have an issue. You just get rid of the index. So we went with forced plans, and now we have queries with high variation. High variation is not exactly as request queries because it doesn't look for queries that have improved or have regressed, they have a worse performance. You just look for queries that have a variation even within the same interval. So it's not that maybe your average is the same as it has last week, but if your queries right now are having variations, let's say one query let's say last week all your queries took 10 seconds, but now some of them are taking 5 seconds, and some other are taking 15 seconds, that will be considered high variation. That is something that you might be interested for, because maybe that variation is caused by some external factors, like some other queries accessing the same table and generating logs. So there are a bunch of things you can be investigate for that. Then we have the weight stats, which is another of the reports. And you can see on your query on the last hour, which is always the default, you can see what was your database waiting for. In this case was buffer IO, then preventive or CPU. So let's say buffer IO, when we click on it, we can see all the queries that were waiting on buffer IO. And you can see here it was pretty much the only query that is running here. And you can see here what were the metrics extracted. And back to the slide, we have the track queries, which as you can see, you've seen, you can use to track one specific query and filter that out with none of the noise of any other queries, no other graphs, just the plain query and its execution plans. That only. In addition to the information you can get from the UI, you can write your own reports. So maybe you want to know which ones of your queries take longer than 5 seconds. Let's say your queries are loading data for the website, and if it takes more than 5 seconds, a user gets frustrated and go to another website, or just start complaining about the latency or complain about the issue with the browser. You can find out which ones are struggling to log in with the transactions or network queues, how many failed with errors or were terminated. And since you can have all this information, why not publish a report or send an email? There might be someone interested in knowing when a particular query execution is executed. When a particular query is executed too often or too slow. And for that, we have this. The QDS QDS Toolbox is a collection of open source tools developed to ease the management of query store. It's built on top of query store tables and views. It also uses, some of the components use some store procedures also for query store, and it's able to generate highly customizable reports. And as an additional feature, it can also store those reports for later consumption. We're going to see how demonstration of how these tools compare to the reports that query store has. Okay, so we have here this. The first one is the server top queries. As you can see here, you have these top resource consumers for the database, but this one will be able to generate the same, but on the server overall. So there are a bunch of parameters here. I'm just gonna run it once, and then we'll see the results. Okay, that number 2 is the report I've run. Okay, so first, we have here the parameters that have been used for the report. So this is the second report. I ran one yesterday for test of this. The time that is being captured, all the data here are on UTC because Query Store internally uses UTC. The server identifier, since this was this SQL instance is a renal container, this would be a very weird server, so I decided to give it a name. The database name, I decided not to specify a specific database, so this is information from all the database on the server. The start time and the end time of the report. Sorry, not the report. Well, let me change that because this is from another test. The dates are a bit older. Okay, that's better. So this is the start and end time from which I'm starting this information. And what I'm starting is the top 10 CPU time queries. I also included the query text on them. And I decided not to exclude the other queries and not to exclude the internal queries. The internal queries being updates statistics, index rebuilding, all that stuff. So let's see what the report contains. So, sorry, not then number 2, the number 3. Yeah, here it is. So these are the top queries that have been running in terms of CPU time in the server for the last, I think, for a week. I think I selected for a week. So we can see what were the top queries on the AdventureWorks database, the top queries on this QDS Rainbow query I created, the QDS Toolbox, and a bunch of queries I have. So this will let you know just at a quick glance what was the top query that was running at any time on your server. So there are more reports similar to this that mimic whatever the management store reports will get. Let's see, I have to change the dates here to use the ones from today. So I think it was 1941. So I started at 1939. And for the end time, 1942 and 1940, say 45. So let's see if I got it right. No. It's tricky because I have to find that exactly the minute. Let's see if I got it right from the previous demo I ran this. There was something on the cache. No, here I have the parameters I use. Yeah, I'm not going to try to guess what was the exact second that the variation changed, the query changed. But yeah, I think I might have the older reports here. Yes, I think I have the reports here. So what I did here was, okay, I'm just going to run these two so you can see side by side the details. So last week I ran some demo and captured information. The kind of information I did was I was looking for regress queries. So sorry, I was looking on this particular database using the duration average. Was looking for the regress queries. That's what the R stands for. And for those the top 10, and these were just the start time and the end time of the recent period, the history period to compare, and then some additional parameters here. The minimum number of executions I was looking for. So let's say you are only interested in looking for queries that have regress because they've been running more than 20 times and not just the one that run once. Also, the minimum number of plans you want to aim for. So let's say if you want to look for queries that have regressed because they had a new plan, for the minimum plan count, you will be using 2 or 3. Otherwise, you will also have queries that have regressed, but with no new plans. And the same with the max plan count. So you could filter out just the queries that you want to investigate. Let's say you only want to investigate queries that have whose performance has regressed or improved, but not having a different plan. So maybe it's because some other queries that were causing locking are no longer there. And in that case, the plan will be the same, and you're interested on those ones only. And this is the result of the report. When I did these other tests, I found only one particular query. This is the query ID at that time, the ID of the object that this particular query belonged to. As seen before, the duration was measuring the average duration, which was measuring microseconds, the measurement change, the measurement in the recent time, in the historical record, what was the number of executions in the recent period of time, in the historical time, and the historical period, the number of plans that were found, and also the query text that was used. So it's pretty much the information you may be getting from the information you'll be getting from the reports, but this way you can, as you see that I had to use, you can store those reports here on disk, and you can go back later to them anytime. You can get information from query regress, query improvements, just changing one flag, and similarly you can get information about the weight variation. So let's say you're making some changes somewhere in the indexes or some other process that was running alongside your particular queries or in parallel with them is no longer there. So you want to analyze what was the impact on the weights. Maybe the weights have reduced in amount, or maybe there's something else that has increased the weights on some other metrics. You can get that information. I had some tests also last week. So this particular one, I forced some logs on the process while I was running it. I was looking for queries that regress in terms of locking. And what I found was this particular store procedure, also the same one that I was doing the previous time. And I see all the variation, all the metrics. As you can see here, there are a bunch of them. So here I can see the variation in terms of number of executions. There we can see the variation in terms of CPU, which was nothing at all. And the one I was interested in was just looking into the log, the logging on the table, the log that might affect this query. So since I don't really want all these columns, which are, I think it was about 30 or 60 of them. And if you're looking for this log rate governor, which I don't remember which one was this one, you don't want to scroll all that. So there is also a step procedure that will clean that up. It will just read the information that you use for the parameters, and based on that will generate a query with only the specific values you're interested for. So that will give you a much cleaner report back. Okay. So as a recap, we have top queries on a particular database, top queries on the whole server. So it's very useful. We use it almost every day. So when we have a complaint about CPU peaks on one particular server, we can just go to the server, see which one of the queries on the whole server is causing all these issues, and when we can just go straight to that. Regress queries on a particular query, or sorry, on a particular database, or on many other databases. Query improvements, which was not included in the SQL store reports. the analysis of the query weights, which I didn't really like the way that the Management Studio generated the report, so that's why I generated a similar one. And yeah, I just realized that there was something interesting here. Yeah, let's see if I can get something real quick here. Not this time. Okay, let's see if I got something from the previous test I did. Yeah, I think I have some information here. So this weight analysis will take whatever queries you are interested on, the interval you're looking for, and as you can see, these are the intervals I'm looking for, and we have the total duration of the stop procedure, for particularly it will be here it will be the query, and we have the total CPU serial times and then the wait times. So let's say, okay, I know how much my query took. Let's say this particular one took, I think that will be 13 seconds, I think. But out of that, you can see that there were only 2.4 milliseconds of CPU time, 414 microseconds of serial times, and all the rest was just waiting. And what I was waiting for was pretty much all wait logs. So you can see exactly out of all the time that my query took to complete, what was the culprit. Maybe it was not always the CPU, was not the network I/O. Yeah, here you can see what was the particular resource that caused the waits on that particular period of time. So with that, we also have the width variation that I mentioned earlier. And for all this, you can archive the reports. So there are a lot of things you can do with all these reports. So maybe you want to start the day with you're receiving an email with all the queries that regress on the previous day or the top queries on the server, and start working on them to improve the performance for the coming day. Or if you are part of a multi-level team with a bunch of guys on the primary level of support, just receiving calls from the end users and things like that, you could instruct the first support level to just, okay, when someone complains about timeouts, run this query for me, archive the report, and then I can just go through that because maybe they are getting too many calls a day, or maybe they are 24/7 and you don't want to be called at 6 a.m. because someone is complaining about some timeout that they receive only once. So maybe this is some kind of report that you could be used later, but it's not critical for you to check it right now. Also, if it is something critical, you may want to get this information stored somewhere so you can just later on analyze that. In that case, in case of a post-mortem analysis, you can generate these reports and attach them to the reports. But after all this, maybe you think that Query Store will not fulfill your needs because, okay, let's say you have multiple copies of the same database for different clients, and you can't compare the data between all of them. Because as you can see, even if you know the query, the code, it might take a while to just find the query on each of the databases. Compare the plans is also not that easy task because they might have, as I showed you before in the Rainbow Queries example, you can have dozens of different plans. So it may be a bit hard to compare the results from different databases. Also, not only just between databases, but you can compare data between different servers. So you have the same database. Let's say that you only have one database, your application using is only one, but you have the development environment, the Q&A environment, the load testing environment, and the production environment, all of them in different servers. You can't just compare the impact of every single query. You will have to open Query Store on every single one of them, go through every single one of the queries, and compare the graphs. So that can be done. If you have too many, it's just impossible to do that. And let's say that you have a plan that you know for sure you know for a fact that this is the best plan that the query store can come up with, but sometimes it uses another one. And let's say you want to force the plan everywhere. For that, you will have to find out what was the query ID of that particular query on each one of your databases. Then you'll have to identify what was the plan ID for each one of these databases. That's hard because the plan ID and the query ID are specific to the database. So let alone if you have to go check that across all the servers, that will be a pain to do that manually. And even if you have the reports on this of the same database, the reports, you might have just too many databases, or maybe you have multiple different databases that are being used by different applications. There is only so much time of the day to monitor all of them, and you can just have one or two people on the team just reading through the emails and deciding which one of the queries are the ones worth investigating today. So yes, Query Store is a great tool if you only have a handful of databases, or if you only care in particular for one of them, or for the developers so they can just make some change, see how the performance is improving or is being, or the query has request when they're making some changes. That's something that can be done on a smaller scale. But when you have too many databases to compare or too many servers to compare, that's something that is impossible to manage. So in Channel Advisor, we face that exact same issue. When I joined, I was still in my shadowing. A colleague was just sharing the screen with me, and I saw the Query Store. I thought, okay, it's cool. We can use this to investigate any issue on the servers. It's really easy. And then he asked me to connect to one particular server, which had, I think it was 400 or 500 databases, and say, okay, it's no way I'm just going to go through every single one of these 500 databases and find out which one is the one whose queries are messing up things. So we decided to use Query Store, but in a different way. First of all, we standardized the configuration of Query Store on all the servers. We wanted to make sure that the intervals on which the data is aggregated was the same on all the servers. Wanted to make sure that the data capture mode that was configured will be the same on all the databases on all the servers. And after we did that, we developed a custom tool that will get information from every single Query Store database and aggregate that into a central one. We call that Central QDS. I was in charge of aggregating the data and then copying the data from each database to the central one. And then a colleague of mine was the one taking care of all the aggregation, doing the final metrics. So we will be able to compare one particular database with another on completely different server, or compare the same query across all the servers. So that's something that another colleague did. By doing this, we also save some space. So you have, let's say, 1,000 different databases, and the same query is being executed on every single one of them. If you account for the execution plan and the query text, even for those that may look small for you, that might take just, let's say, 1-2 megabytes for each query. 1-2 megabytes per query, you multiply that by 1,000 different databases, that's 2 gigabytes. So while we were doing the aggregation, we also group all these plans. We identify the ones that were duplicates, we ignore them, we clean them up, we compare the information. So right now, for 1,000 databases, one query can take only a few kilobytes compared to several megabytes it used to take on the Query Store when it was deployed on every single database separately. And finally, to get this information, originally we will be using just the SQL to extract information, but that could be overwhelming for some people that was not aware of how this was working internally, how all the data was aggregated. So we generated some Power BI dashboards. Pretty much was my colleague Efrain Sharon. He did the dashboards, and I was just copy and pasting them and making tiny changes. So we have some Power BI dashboards that emulate somehow what you will have with Management Studio, but with the difference that This will let you compare server information across millions and millions of rows of information, thousands of databases. So we have some dashboards, but I think I finally managed to get one demo working. So let's see if Power BI starts. I may be able to show you one live one. So one of the dashboards we have is the query performance. See, I'm just taking a look. Just see well if Power BI crashes or not on my other screen. So you can see whether your queries are performing overall. So maybe you think your queries is fine. Maybe you think okay, my query is perfect. It's not having any issue. I don't know why it's complaining this particular client, but maybe that query is not working fine for all the clients. It's only working fine for one of your clients. So you may want to know what is the impact of each query on your databases and servers, whether the performance has changed over the last days, and which one of the databases and servers is being hit the most by a query. So maybe you have some particular report and you wrote on thought, okay, this takes a ton of CPU, but nobody will ever use that. And you have one particular user that is using that every 5 minutes for whatever reason. So yeah, here is the report. So obviously everything is obscure, all the schema objects. This is not the name of our schema object. That would be awful. It's also the server names are not the same, but this is real data. So this is extracted from one of the server types, and you have a bunch of dashboards here to choose from. So let's say you want just this initial one that was based on some requests from the DB database engineers. They wanted to have this on the initial landing page. You can see here you have the executions on top, duration average, CPU average. You can see some peaks here. And let's see if I can just, if I'm lucky to select one. Okay, one particular query that, yeah, not too good. Let's see if I can find some other. Yeah, so, well, not good, not too good either. So this here, we can see that it's been executed how many times. We can even click on that and see on which database it has been executed, what was the average duration on each of them, and the duration also on each of the servers. There are a bunch of metrics here. You can see we have the total duration, CPU, and 10 dB. We have the same for the average on the same metrics. We have one specific dashboard just for the I/O, be the logical reads and write, the physical reads, and something else that we have for the execution results. So let's say that your application is for whatever reason is not logging all the executions. So you can't tell exactly when it failed or how often it failed, because it's not something that you can see on the logs. With this, I'm not even going to try to find one with the proper metrics here, but here you will see for each query how many times it has been executed successfully, how many times it has been aborted, and how many times it exits with an error, which will be the exception. And if you notice this chart here on the right side, yeah, because of how this chart works in Power BI, there was only one metric. This particular one was the average CPU by server, by FQDM. And there were a bunch of them, so there are some dashboards just for this chart, which, since I filtered that out, okay, let me remove the filter. You can see the top queries in terms of the duration, CPU, and all that. And for our particular needs, we were using to generate some queries entity framework, and we wanted to know what will be the impact of the entity framework, what will be the impact of maintenance activities, or what were the impact of queries that belong to specific objects, which are the ones that are the most being used or should be used the most. So we have this final dashboard, which, well, here you can see it very clearly that We have in yellow the ad hoc queries, queries that don't belong to any particular object in the database. We have here in green the maintenance of operations. As you can see here, we have much more activity on the maintenance side that we do on the ad hoc queries. And I'm guessing that these days, because this is 1 day per bar, these days there might be some activity that involve generating some ad hoc records, ad hoc reports, or generating some or executing some custom queries that were not part of any object. And then here we have just the queries that belong to any object at all. So that's pretty much what one of these dashboards can do. This was one of the smaller dashboards we have. We have one that I think it was, yeah, it aggregated about 2,600 different databases, and it was loading really fast compared to the amount of data that we'll have to go through if we have to use the regular reports and go through each of those databases one at a time. So since I managed to get this, I'll probably have to, yeah, there are a lot of things here I have prepared in case I wasn't able to load the demo, so we can skip all these. Yeah. What a waste of time doing all these slides. Okay, let me see. Okay, this was a very bad joke that was just meant to introduce one of the dashboards, so we can skip that. Yeah, there is also one dashboard based on object performance. So in the previous one, you could see that one particular query had a certain use of CPU, memory, or whatever, but you don't really know what queries you have. I mean, sometimes you have a stored procedure with thousands of different lines, and those lines might be hundreds of different queries. You are not going to go through each of them, all of them. So let's say, okay, I'm just looking for the queries that require the most CPU or that have regress. 1% regression of each one of the queries on the stored procedure might not be too much, but if the stored procedure takes 1 hour to complete, it might take a bit more. So that will be what do they call the advanced outcomes. The individual queries might not look too much, but when you look to the overall, it will be a huge impact. So we have a dashboard that is pretty much the same that the query store. That the query performance dashboard. I wasn't able to do a sensor version of this one beforehand, but you can see this is only the schema on object, and well, you can see the average duration in the last 2 months is only 26 seconds, or microseconds. I don't remember what metric I use here right now, but you can see that there are some databases where that particular stored procedure took 5, I'm gonna say, seconds or 2.5 seconds. So when you're investigating in this, maybe those are the particular ones that you're interested in. Maybe I don't know. Maybe you forgot the index rebuild operation on those servers, or maybe the statistics are way off on the server, or maybe the user or the information that the user, your client, is loading into that particular database is huge compared to the average ones. Let's say that maybe they have 1 trillion rows compared to 1,000 rows that all the others have. So maybe this is something that can help you identify what were the databases that are performing differently and figure out why is that. And there was also some weight information on the query store, so I thought that, well, we could use this to do some analysis. So in this way, the whiteboard, you can find the weight type per category and date. As you can see, it's mostly generated by CPU in orange. And if you select a specific wait time, you will see here which object spend the most time waiting on the particular resource. So, okay, I know I have a CPU constraints, but what is my CPU constraint affecting the most? Or you can have all that for specific queries. There is another way of getting this information from. Okay, so for one particular server or database, you can see, well, this is just another representation how the CPU is the biggest one, is the biggest wait stats. The second one will be the buffer latch, and so on and so on. And here you will have the information from every single server and database. So a summary of what Central QDS has. You have all the information from each of your databases on a single one. You no longer need to keep query store data for the last year on each database. I recently read a post from Erin Steliato talking about one client that had 100 gigabytes of just for store information on one particular database. That's huge. It will take a long time to stop that server because you have to flush that data to disk. It will take a long time also to start that database because it will take a long time to load that information from these two memories and all the stuff in memory. This way you can just have, I hope you're still, okay. So this way you don't really need to have a year worth of data in each of the databases. Since we implemented this, we only have 30 days worth of data on each database, and then we have, I think it's between 1 and 2 years of data in Central QDS. Also in Central QDS, we aggregate that per day instead of per 15 minutes, per 5 minutes. So we also save a lot of space there. The reports are, in my opinion, easy to understand, and I hope everyone can understand how easy it is, because we usually use for managers, they use for the presentation. So you can see, okay, we have an improvement here. You can see how the performance drop, how the CPU usage drop. So you can see that we really are doing some progress here. And the reports are completely customizable, and you can do it yourself. The ones we use are running on Power BI, but with some other BI solutions, you can just do them however you feel more comfortable with. And the thing about Central QDS, how to get it for yourself. So QDS Toolbox is already released. Sorry, it was already released. Was I think yesterday in Channel Advisor GitHub. I will just share the link later. And Central QDS, there are good news and not so good news. The good news is that it's also going to be free and open source, and that will be published in the same GitHub from Channel Advisor, not the same QDS Toolbox. It will have its own, but it will be there. But the not so good is that it's currently under code and documentation review. We have been using this for more than a year, but right now I'm just reviewing the code, making sure that everything has error captured everywhere, enough verbose messages to anyone to comprehend that, and also including documentation for all the things that were being developed on the fly, and there was no time to document at the time. And because of all that, there is no specific release date, but hopefully, if I have the time to complete with that, and my colleagues can help me with the final reviews, I'm hoping that in the first quarter of 2021 we'll be able to release it. Okay, so if you are convinced to, I don't know if you are convinced to use a query store yet, but before, let's gonna see some things that I think it's important for you to understand about query store before you decide to, okay, let's go crazy and install it anywhere on my servers. So we're gonna see what are the configuration settings, so you understand how they work. Okay, so we have the operation mode. So the operation mode, query store has several of them. well, pretty much only 2, because if you use the interface, we will show you that it has 3, but it's actually only 2. You have the read-write mode that will just, as you can hear, as you can understand from the name, it will just be letting you read and write information from query store. The read-only, that is just for reading information that is already stored in query store, and it will also be the mode that it goes back to, it reverts back to when you're running out of space. Then we have the cleanup policy. There are several ways that the query store cleans itself up, and this is one of those. This cleanup policy means that any query or any statistic that ordered at one day will be cleaned up. Then we have the interval length in minutes. This is how often the data is being aggregated. So if you really need information of every single minute, what was the average duration one specific minute, you will go with 1 minute. Otherwise, you can go with 15 minutes, 1 hour, or just even go up to a day. Data flash interval seconds. This is how often this information from the intervals is being stored. It's flashed to disk. I usually have the same interval that I use for the same interval length that I use for the data flash length, but it's just me. Then we have the max storage size for query store. This is a tricky one because query store will always be stored, its information will always be stored in the primary file group. There is no way to change that. So if you are working with very small database and very small servers, you have to account that if you go crazy here and say, okay, let's say 100 gigabytes, make sure that you have 100 gigabytes and there will be no issues, because you may end up having 100 gigabytes of query store and no space for your actual data. Then we have the size-based cleanup mode. This is just something that you can enable or disable. There's no settings for that. And this kicks in when the space used by query store reach 90% of whatever you have here in the max storage size. It's something that it's being enforced every time you flush to this. So in this case, 60 seconds, query store will save your information to disk. We'll compare it with the maximum. We'll compare the size that it was taken with the maximum storage size. If it is higher than 90%, we'll kick off this size-based cleanup. I will explain it later if I have the time. And if it exceeds the 100%, the query store will just go straight to read-only mode. More parameters here are the maximum plans per query, which, as I saw earlier in the rainbow example, they can be pretty big. But I think if you have more than 10 or 20 plans, you may have another issue with cardinality that's just more important than just changing this value here. With that capture mode, this should be on. I don't know why I'm always making that typo. So you can decide whether to capture stats, weighted stats or not, because this was not included in the original version. That's why they added the possibility for you to decide whether to include that or not. And then the query capture mode. So we have different modes. The auto capture mode, that the SQL server will decide which queries are being stored, what are the metrics that are interesting or not. The all capture mode, that will capture everything that's running on the server, which is the one I've been using for my demos, because otherwise I will have to figure out some query that takes, okay, I need this to run more than 2 seconds of CPU or run a number of times. So I just went to all. And the custom mode, which is a new one for 2019, it has 4 values that I tried to prepare a demo, but somehow it didn't work as expected. So you have 4 different settings here related. You have the stale capture policy threshold measuring hours. Okay, this I will explain later. So you have the execution count set to 10. That means that you won't capture any query that is executed less than 10 times in 4 hours. Total compile CPU time in milliseconds are the same. Any query that doesn't take to compile 100 milliseconds in the last 4 hours will not be captured, and the same with execution CPU time. When I read about this, I made some investigation on that, and I found that the custom mode uses, I think it was the 1 hour threshold, execution count 30, and the compile time I think was 1 second and 100 milliseconds for CPU. And there was something weird on that. I changed the settings and I decided to capture, okay, I'm just going to capture queries that have been executed 10 times. Okay, so I set it 10 times. I executed the query once, twice, 9 times. Then I executed the number 10th. And when I was expecting the query to pop up and look like it had been executed 10 times, it only showed as executed as once. So somehow the data, the metrics before reaching the threshold were lost. And I found that was happening the same with the compile time and execution times. But when I was preparing the demos on the script for today, that was not the behavior I saw. So I don't know whether it was a CU that changed the behavior, or maybe it's because of random containers. Whatever the reason, it was no longer the case. But I know that I know for a fact that was how it was working, because I even wrote a long blog post about that, because I was furious about how crappy this kind of capture mode was working on. But for some reason now it's either fixed or I wasn't able to emulate that. Okay, so I realized that I thought I wouldn't be getting my 60 or 75 minutes, but I think I'll have to skip the extended events. There are a bunch of them, mostly under the QDS package that include all the information. You can capture when it's doing some cleanup on the server. You can see how many queries have been cleaned up. You can see when query store is looking for existing plans, whether it has find a plan good enough, when it had some issue trying to force one particular plan. You can have all that kind of information there in the extended events. And we are going to see some potential issues you can find on query store when you deploy that in production. Well, the custom capture, as I explained already, so I'm just going to skip that. The standard events, not much time. Okay, some of the issues that query store has. Time tables and table variables. Here you can see that the query is a very simple one, and notice here the index name. It's one of the auto-generated ones. So it will change every time. The SQL Server, if you try to force this plan, it will not always use the same plan because of this thing. It also doesn't ever again use the same plan. Somehow the SQL engine sometimes remembers that well, I'll have this plan that was pretty much what I wanted to do, but it's not always working. So I think I should have some example here. No, this was for the custom capture mode. Here, the temporal tables. No, I don't remember what was the plan for this demo, and I'm running out of time to go through all the slides. So yeah, just trust me, there is an issue with that. You try to force the plan, and then we will just plain ignore you. And the workaround, which, yeah, I just remember that was why I created this. If you name the PK, it will use the particular PK. So let me see. Here you have the execution plan. You can see this PK underscore T3213, whatever. So that's something that if you try to force the SQL Server, most of the time will just ignore you. But if you name your PK, even if it is a temp table. Here you can see the PKID, which is the name of the index I created. And this is something that you can force. Sometimes you will not force it because temp tables and cardinalities don't get on very well with the query store, but it's something that most of the time will work.
Quick reminder here, Pablo, you have 15 minutes.
Yes. Yeah, I have my timer here, but I spent too much time on the initial demo, sorry. And then we have the, as I mentioned before, the automated size-based cleanup. So as I mentioned before, it kicks on when it reaches a 90% threshold. It's CPU-based only. So I mean, it will ignore, it will just go through all the queries. I will delete anything that it considers that has very low CPU usage. So let's say you will scan all your queries. Just imagine that just imagine that yourself are just querying query store, the information it has, and say, okay, I want all this information ordered by CPU, which is not one of the orders that query store is based on. So you have to scan that information, aggregate the information because you want to see all the queries along for the last month or so. And you have to order all those queries on CPU, find out what are the ones that consume the most, and one by one start deleting information from them. So this is no only way, and it also takes a long time. When it releases up to 100%, sorry, 20% of space on query store. So when you have roughly 80% of free, but not always, it will stop the process. This process, this cleanup process can consume a lot of CPU. And by a lot, I mean, once we saw a 8 cores machine, was having, I think was about 50 or 60% of the CPU being used just for that. So just for that kind of cleanup. So that can be an issue. And also, query store is not that clean. There are at least 2 things so far that I found that query store will not clean up, even when you're using the size-based or the date-based cleanup. Statistics is regarding force plans and dropped objects statistics. So when you force a plan, no matter what, that plan will never be deleted automatically unless you force the deletion of that particular plan. And also, if you drop an object, the object is not there, so it doesn't make sense to just investigate what happened to the object. You can't get, you won't get rid of these statistics unless some time has passed, the data has been already considered as stale and it's been dropped, or unless the CPU, the size-based cleanup kicks in, and for whatever reason, those particular queries are the ones that have been selected for deletion. So let's see what happens when those 2 situations happen. So you have one query with, you have one object with some queries on it. Each of those queries might have different execution plans. As we said before, there may be dozens of them even. So you identify the optimal plan, and you force that particular plan. There it is. So you make a change, and for whatever reason, you decide to drop and recreate the object, which is something that, since I've been using query store, I don't recommend at all. So you have the new object, and the cleanup will eventually catch up and clear the metrics for all the execution plans, or all but the ones that you force. In the meantime, the new object has created its own plans for the new queries. So now you have some problems. You have the execution plans that will never be deleted because they are forced, and SQL Server will never delete these forcing plans. And they will never be used because even though the query is the same, the object is different. And since the plan is associated to that query, and the query is associated to the object ID and not the object name, you will have to look for the new plan, look for the plan that looks the same than the one you were forcing, on that is good enough or similar enough, and just force it now on the new one. So since we suffer this issue, we decided to create some other component for the QDS Toolbox, which is this custom cache cleanup. It will let you delete the orphan orphan object stats, which is something that otherwise you will have to wait for SQL Server or the query store to catch up. You can also select to delete information about the internal queries, update statistics, index rebuilding, all the stuff. Delete the stale queries that you decide with some parameters. Okay, let's say for me, a query is stale when it's not been executed more than 3 times in the last week because it's not something important enough or whatever. So you can select that information too. You can save a report of the deleted data so you can understand exactly what has been deleted from the cache. And you can evaluate different parameters for that. So let's say, okay, I don't trust this procedure right out of the boat. I want to try out what will happen if I select this particular query, or what will happen if I select this particular parameter. What will be the impact here? So you can use different parameters and store information on what will be happening. So when we had the automatic cleanup, this consumed 60% of CPU on an 8-core box. And after that, we used 6 parallel custom cleanups, and it took less than 3% of CPU consumption. So, and I'm guessing this was 3% CPU because we couldn't narrow it down exactly to a particular process, but we were using resource governor for that, and we couldn't find any peak over 3%. And we had a higher space gain because of the orphan queries that were deleted and all that. We reduced it up to, on average, on all the servers we've been running this, we clean up to a 20% of space compared to the 10% that the automatic cleanup will give us. And the automatic cleanup will not let us decide what information we wanted to keep and what information we wanted to get rid of. I think there is still some time. So with these queries and some others, we decided to combine query store with some other tools. Let's see if this is this is the slide. So we decided we already had a Grafana installed, and we used to monitor our servers to see get a graphical view of how they will look like. So we combine Grafana with the InfluxDB database to store information, and Telegraph to gather information from each test server to Grafana. And with that, we could get this kind of reports. Again, everything is tensored by, you can see here these CPU peaks, and each of these bars represents one database. So we could see exactly which one of the databases was the culprit for each of these peaks on the CPU. We also have here TeamDB and query memory, but all the metrics that you have on Query Store, all those metrics you can use for this kind of reports. So what we can do is, when we have a server with some particular issue, we can just go to this tool Grafana, see which particular database is the one consuming most CPU according to Query Store, and then just go straight to the database, and we can use either the toolbox, or we can use the integrated reports to get more information from the particular database. Okay, so please use Query Store, the feature. It was is free, and it's including all SQL versions starting 2016. It can save you time and money because it will help you identify the queries that are causing some issues, making you consume more CPUs. Maybe you can save CPU and not have to invest in more machines. And you can disable it anytime if you're having some issues, so it's not a problem at all. Although it has some bugs and lacks some features or some weird things like this cleanup or the custom capture mode that I don't really like, the more users that it has, the more bugs will be reported and found, and the more fixes and updates it will receive, so they will be more stable for the following users. And also, you have some very colorful reports you can use for your manager. So explain, okay, you remember this change we made? Okay, well, you can see how the CPU is down, or how the network usage is down, and you can see some rainbows, as I mentioned before. Okay, and at last but not least, remember that if you need some help with Query Store, you can use our tool, the QDS Toolbox. We'll be adding more functionalities. When I was just about to deploy and release that, I would realize that there will be 4 or 5 more functionalities and functions that I wanted to add. So I have to hold back and just decide, okay, just release it as it is, and then we'll release something else later, because otherwise I will be never releasing that and will be always adding more things to that. So that's all. My name again is Pablo Lozano Fernandez, a SQL Server Administrator and Channel Advisor, and you can find me on my blog, on Twitter, and on LinkedIn.
Okay, Pablo, I have a couple of questions for you.
Yes.
If you and we have about 4 minutes, so
Sorry.
it's okay. So the next speakers, by the way, if you want to go ahead and start making sure that you can like share your screen and all that kind of stuff while we answer these questions. That way you can just start right at the top of the hour if you want. So Query Store and all of the stuff that you showed us today, is there a considerable impact on performance?
Yeah. Well, this was implemented right before I joined the company. But what I heard from the DBAs that were here before, I think they will notice a drop in the average CPU usage in 20%, because all the automated tuning that Query Store does. So it had an impact on that side, but also consumes, I think, was that's an overhead of, I think it's about 6 or 7% of CPU on the servers overall, because it has to keep track of all these metrics, all the execution plans compared with the own. So it has check whether there are some force planned or not. So it has some overhead, but there was an average of 50% of drop. And since we have been using that, we keep finding some issues, some improvements to find. So every month, the lead of the database engineers generates a report that says, okay, we have improved this process, and we save that amount of time on CPU on all the servers we have. We have improved the performance on that particular process.
So it's a trade-off. So it's a trade-off,
yes.
right?
Yes. Yeah.
Okay. So last question. What are your preferred configuration settings when activating the Query Store?
Well, we usually have the interval between 5 or 15 minutes. I don't want that to have more than that, because otherwise it will be harder to find regress queries. We usually, when you want to find a regress query, it's not something that, okay, just let me wait 45 minutes until this interval closes, so I can actually see what was regress in the last hour. So it's usually 15 minutes for that. And for the capture mode, we use the auto capture mode, because the custom one was not ready there. I guess that when we start migrating to 2019, we'll be using the custom mode, but before that there will be probably a transition between the auto mode to all capture mode, and then we'll be working with the custom mode to select from. So I would suggest, if you have a small box, just start with the capturing all the queries, and then just going with the custom mode if you are running a SQL Server 2019, and just tweaking the values, the threshold, so you will be able to capture all the information you are interested in.